Hello viewers, welcome to my channel. The diagram before your eyes is the detailed explanation of production of sulphuric acid or tetraoxosulphate 6 acid in the industrial process known as contact process. It is said that the prosperity of any nation depends on the amount of sulphuric acid it can produce. This is true because sulphuric acid plays roles in our daily lives, industry, commerce, and what have you. In fact, life becomes almost meaningless without the application of sulphuric acid. Be it in industries, your car cannot start without sulphuric acid because the car battery is manufactured with sulphuric acid. That is just an instance. The brewery cannot exist without sulphuric acid because the ethanol there is produced with sulphuric acid. Reaction between sulphuric acid and the tea gives ethanol, and many other processes. Cosmetic industry, the pharmaceutical industries, all these industries depend on application of sulphuric acid. Now let's move to industrial production of sulphuric acid, or what is industrially known as contact process. The starting material for contact process is air and sulfur, or air and pyrite. If you look at this first chamber, you see that air is pumped into the chamber where it reacts with sulfur. The component of air that sulfur attacks is oxygen. So sulfur reacts with oxygen to give sulfur 4 oxide. Or if pyrite is used, pyrite is FeS2. That is pyrite. If it is used, it reacts with oxygen to produce iron 3 oxide and sulfur 4 oxide. To balance the equation, iron is 2 here. So coming to the reactant side, you write 2. Now sulfur is 2 times 2, 4. Coming here, you write 4. Oxygen is 4 times 2, 8, plus 3, 11. Coming here, what we multiply 2 to get 11 is 11 over 2. Oxygen is balanced. So to remove the fraction, you multiply everything by 2, which is the denominator here. So multiplying by 2, 2 times 2 will give you 4. 4 FeS2 plus 2 times 11 over 2 will give you 11. 11 oxygen. To afford 2 times Fe2O3 is 2 Fe2O3 plus 2 times 4, 8 SO2. So the essence of doing this burning pyrite is to produce sulfur 4 oxide, which starts the journey to production of tetraoxosulphate 6 acid. Now this sulfur 4 oxide produced is full of impurities. Oxygen is there, water vapor is there, dust particles, and what have you. So what happens is that from this pyrite burner, the next chamber is called Purification Unit. Inside the Purification Unit, there are chambers. And the first chamber in the Purification Unit is dust remover. In this dust remover, steam, that is a hot water vapor, is sprinkled into the sulfur 4 oxide with its impurity, impure sulfur 4 oxide. And what happens is that this steam, what it does is to dissolve dust, remove dust from sulfur 4 oxide. And the dust settles here. The next is that sulfur 4 oxide moves out of dust remover. And the next chamber it enters is the scrubber. The scrubber. In this scrubber, what happens is that cold water is sprinkled. And what the cold water does is to remove water-soluble impurities. Any impurity that dissolves in water, the cold water dissolves it away from the mixture. And the journey continues. The next chamber the sulfur 4 oxide enters is called the Drier. Of course, you know that sulphuric acid is a drying agent or dehydrator, a dehydrating agent. So what it does is to absorb any water vapor as impurity. It will absorb it off the mixture, leaving a dried gas which passes to enter the next chamber, which is called arsenic purifier. This is where any possible arsenic impurity is removed by iron 3 hydroxide. After this chamber, the next is that the sulfur 4 oxide is tested for purity in the purity testing box. The impure ones are recycled to be further purified, and the pure ones will continue the journey. And what happens is that sulfur 4 oxide plus oxygen, which is even part of the impurity, will enter a preheater. This is where it is heated to the proper condition of temperature, which is 450 degrees Celsius, which is required for the reaction. Now, when they enter the next chamber, which is called contact tower, the sulfur 4 oxide will combine with oxygen. Immediately it comes in contact with vanadium 5 oxide catalyst. In fact, this chamber is very instrumental to this contact process because this is where the real contact happens. This process is called contact because this is where sulfur 4 oxide in contact with vanadium pentoxide catalyst reacts with oxygen to form sulfur 6 oxide. Now, this sulfur 6 oxide enters the last chamber known as absorption tower. This is where concentrated sulfuric acid is sprinkled, and what it does is to absorb the sulfur 6 oxide to form a compound known as pyrosulfuric acid, or you call it disulfuric acid or oleum. And the equation of reaction is this: SO3 plus H2SO4 will give you H2S2O7. This is called oleum or pyrosulfuric acid. This oleum will now leave through this tap and goes straight to where it will react with water to give tetraoxosulphate acid, which is the end product. And the equation is oleum H2S2O7 plus water to afford H2SO4. To balance the equation, hydrogen is 4 here, you write 2 here to balance it. And this is the target product, tetraoxosulphate 6 acid, produced when oleum dissolves in appropriate quantity of water. And that is it. I hope you can explain this diagram when called upon. If you have any question, you can come to the comment section. Thank you very much for watching.